Hello everyone, welcome back to another video for the series. I'm Q, and today I brought a problem from 2000 year 2000 IMO. Yes, I almost solved this problem, but I couldn't solve it because I don't know. But my approach was actually the same as the starting of the official solution. But it's very unfortunate that I couldn't solve it, even though we had the same approach. So first thing that we should do after looking at this problem is, it was quite natural for me to write it like this: a equals x over y, b equals y over c, and c equals z over x for x, y, z, and positive real numbers. Now, for me, I wrote it like this instead of x over y because in Korea, you call the denominator first. So in English we say y over z, but in Korean we say x 분의 y. So it's like x and y for some reason. So I wrote it like this, but this caused a huge problem later. That caused yeah, I couldn't solve it because I wrote it like this instead of this. No, that's kind of an excuse because at the end it doesn't really matter, but it's really hard to see if we write it in this way. So I think it's better to write it in this way. So writing it like this, we get y over z, over y over z minus 1 plus x over z, lastly 1 plus y over x. Now the problem is when we write it like this, a equals this, then everything is flipped here. So it becomes y over x, y over z, and this becomes z over y and z over x. So right now it's quite natural for all of us to just multiply x, y, z here to get rid of the denominators. But if it was written this way, it's really hard to see. If you have it this way, it's really hard to see that we have to multiply it by 1 over xyz. I mean, it might be easy for others, but at least for me it was hard. So that said, we have x minus y plus z times y minus z plus x times z minus x plus y less than or equal to 1. If we prove this, then we're done. Should we call this alpha, beta, and gamma? Notice that alpha plus beta. So we want to prove that alpha. Oh, this is x, y, z. Oh my goodness. Notice that alpha plus beta plus gamma is equal to 0. No, x plus y plus z. Yeah. So right now, we want to prove that alpha, beta, gamma is less than or equal to. What is alpha plus beta? Alpha plus beta is actually 2x because these two cancel out. So we have 2. Alpha plus beta is 2x. Beta plus gamma is 2y. Then naturally gamma plus alpha would be 2z. Therefore, we could write this as 8 over over 8. We want to prove that this is true. Now recasting, we can write it like this. Now, it's really easy from here to just say that we can use AMGM and prove our inequality. But the problem is we cannot use AMGM directly because alpha, beta, and gamma could be a negative number. So let's say, without loss of generality, no, first case is when alpha, they're all greater than 0. By AMGM, true. Next one is without loss of generality, let's say that alpha is less than 0. If alpha is less than 0, it tells us that x plus z is greater than, less than y. If alpha is 0, our left hand side, notice that our left hand side right here, no, sorry, if alpha is less than 0, then our left hand side must be negative number because negative times positive. I should include this one. Can it equal 0? Yeah, I think so. How about if alpha is less than 0, obviously this side will be 0 or a negative number. How about our right hand side? If alpha is less than 0, beta and gamma are positive. So z y plus x, this is z plus y. So we know that this is true. Then what is alpha plus beta? Alpha plus beta, oh my goodness, I'm so sorry. Okay, yeah, we don't have to do this. Then less than or equal to 0. Alpha plus beta, as mentioned, is 2x. Beta plus gamma is 2y. Gamma plus alpha is 2z. Meaning, if we multiply all of them, this is 8xyz. 8xyz is always greater than 0 because they are all positive numbers. And plus beta plus gamma plus alpha is greater than 0. So this is true. Now, next case would be when, without loss of generality, let's say two variables are negative. Then we get x plus z less than y, beta is x plus y less than z by these two. But notice that let's add these two. We get 2x less than 0, and this doesn't work because contradiction. So this itself doesn't work. Now the last case would be when all of them are negative numbers. But this is the same case as multiplying negative 1 to here. So that wouldn't change a lot. Yeah, and also if you do the same thing, we get x plus y plus z less than 0, and that doesn't work. So we consider every case and we proved our inequality. So this IMO problem used really basic idea of substitution. This is quite famous, I think, and using AMGM. But I think many students, including myself, would have lost points because we didn't consider when alpha, beta, and gamma are less than 0, when they're negative. So I think this was quite dangerous part, and the other ones were quite natural, I think. So thank you so much for watching this video, and tomorrow I'll come back with another very fun and interesting problem. Thank you and see you tomorrow. Bye.